Hi class, in this video I'm going to talk about dividing polynomials. So to divide polynomials, we want to divide number by numbers and the same variables by the same variables. So for this question here, I'm going to try to simplify this. 4 divided by 11 is still 4 over 11. I can't simplify that. However, x to the exponent of 3 divided by x to the exponent of 3, I can simplify. So remember, when I'm dividing variables with the same base, I can subtract the exponents when I'm dividing them. So this would be x to the exponent of 3 minus 3. And 3 minus 3 is going to be 0. So I'm going to get 4 over 11. And then I'm going to get x to the exponent of 0. But remember or recall that any number except for 0 to the exponent of 0 would equal to 1. So what I'm left with is 4 over 11 as my final answer. The other way to look at this question is, imagine once again I have 4 over 11. X to the exponent of 3 means I write x multiplying by itself 3 times. So in this case, this is what I actually have. I have 4 times x times x times x on the top and 11 times x times x times x on the bottom. However, the same number divided by the same number always equals to 1. So in this case, I can cancel out an x with another x because x divided by x is 1. So I can just keep expanding out my x's based off of the exponents that I have and just cancel them out. And once all of these x's cancel off each other, what I have left is 4 over 11 still. So my final answer is still 4 over 11. Okay, now let's move on to our second question. So I have 5 over 8 and b to the exponent of 4 divided by b to the exponent of 4. So this would be 5 over 8. I cannot simplify that. However, for the b, it is going to be 4 minus 4 because they have the same base. Both of them are b, and I can just subtract the exponents when I divide. So in this case, I'm still going to have 5 over 8. I'm going to have b to the exponent of 0. Hence, I'm just going to be left with 5 over 8 times 1 because any number except 0 to the exponent of 0 is 1. And that will leave me with 5 over 8 as my final answer here. Okay, so let's move on to the next question here. 7 times r to the exponent of 6 divided by 3 times r to the exponent of 5. In this case, I'm still going to have 7 divided by 3. I cannot simplify that. For my r, because I'm dividing, I can subtract my exponents. So in this case, 6 minus 5 is just 1. So I'm going to have 7 divided by 3 to the exponent and times r to the exponent of 1. However, any number to the exponent of 1, we can just get rid of that 1. We don't have to write it down. That's usually an invisible 1. So my final answer would just be 7r divided by 3. Okay, for this one, I can simplify this. So 10 divided by 4, I could divide the top number by 2 and the bottom number by 2. That would get me 5 divided by 2. So I can simplify the 10 divided by 4 as 5 divided by 2. As for my v, it is going to be 2 minus 5. So v to the exponent of 2 minus 5. Now 2 minus 5 is going to be a negative integer. It's going to be negative 3. So what I'm going to have is 5 over 2 and then v to the exponent of negative 3. So that could be a final answer. Another way of looking at this is kind of what I did up here when I expanded the exponents, the power. So here I have 10. Because it's v to the exponent of 2, I can write v twice. So I have 10 times v times v. However, on the bottom, because I have v to the exponent of 5, I can expand that out and write v 5 times. So upon doing so, recall that v divided by v is just 1. So I can for every v that I have on the top, I can cancel out a v on the bottom for it to let it equal to 1. In this case, after I'm done canceling out all the v's on the top, I'm left with 3 v's on the bottom left over. So hence, this could be simplified to 10 divided by 4 times v times v times v. So I'm going to have 10 on the top, 4 on the bottom, and v to the exponent of 3 on the bottom. And if I simplify the 10 and the 4 by dividing top and bottom by 2, I'm going to have as a final answer 5 divided by 2v to the exponent of 3. So either of these answers are acceptable, but however, most mathematicians would like the exponent to be positive, so they like this answer more. However, this one is also a acceptable form of the answer, in my opinion. But I guess put it in whichever form that your teacher would like it in. Okay, so let's move on to some more examples. Here I have 11 times p to the exponent of 5, and then on the bottom I have 9 times p to the exponent of 2 times 4 times p to the exponent of 3. So for this one, it looks like I can simplify the denominator first. So I'm going to go ahead and do that. I'm going to leave the top alone because it's already simplified. And I'm going to simplify the bottom. 9 times 4 is 36. So I'm going to have 36 here. P to the exponent of 2 times p to the exponent of 3 is going to be p to the exponent of 2 plus 3. Recall, if I have the same base and I multiply them, I can just add the exponents. So in this case, I'm going to have 11 p to the exponent of 5 divided by 36. And since 2 plus 3 is 5, I'm going to have 36 times p to the exponent of 5 as well. Now, because these are the same exponents, what would happen is I'm going to try to simplify my numbers. 11 divided by 36 is, I can't simplify any further, so I just leave it. Because I'm dividing now and I have the same base, I can just subtract my exponents. And now we're left with the same thing we had before. 5 minus 5 is 0. So I'm going to end up having 11 divided by 36 times p to the exponent of 0, because p to the exponent of 0, any number to the exponent of 0 except 0 is 1. I'm just going to have 1 here, so 11 over 36 times 1, which would just simplify to 11 divided by 36. Okay, so let's move on to another example. Same idea here. I want to simplify what I have on the bottom here. So on the top, it's already fully simplified, 2x squared. Now on the bottom, I'm going to have 6 times 10 is going to be 60. And x to the exponent of 2 times x to the exponent of 6 is going to be x to the exponent of 8. So to simplify this, I can divide top and bottom by 2. So I'm going to be left with 1 here. 1x squared. And 60 divided by 2 would be 30. So I got 30x to the exponent of 8. So now I can write this in two forms. If I divide these, it would be x to the exponent of 2 minus 8. Or I can use the trick I did here, where I took these powers and expanded them out, and then started canceling out the same variables from top and bottom. So there can be two answers here, or two forms of the answer. This can either be 1 divided by 30 times x to the exponent of 6 on the bottom, or I can say this is x to the exponent of negative 6 divided by 30. Okay, moving on, let's go ahead and solve for these two. So let's solve for the top first. Let's try to simplify that. 9 times 7, I can multiply the numbers together. That would get me 63. Y times y to the exponent, or let's do x first. X to the exponent of 6 times x to the exponent of 3 is just going to be x to the exponent of 9. Y to the exponent of 1, because there's an invisible 1 in front of my variable, doesn't have an exponent. Y to the exponent of 1 times y to the exponent of 2 would be y to the exponent of 3. Okay, that's simplified on the top, and I can't simplify further on the bottom, so I'm just going to leave it now. Okay. Now, 63 and 11, I can't simplify that anymore. However, I can simplify x to the exponent of 9 divided by x, and y to the exponent of 3 divided by y to the exponent of 2. So what I'm going to get is 63 divided by 11, x to the exponent of 9 divided by x to the exponent of 1. That's going to be x to the exponent of 9 minus 1. So that's going to be x to the exponent of 8. And y to the exponent of 3 divided by y to the exponent of 2 would just be y to the exponent of 3 minus 2. So I would just be left with y to the exponent of 1, or just y. And that would be my final answer. I would just put the 11 a bit more in the middle here. And yeah, so this is another example. I'm going to simplify what I have on the bottom, because what I have on the top looks like it's already fully simplified. I'm just going to rearrange this and put the x before the y, just because I like to keep things alphabetical. So here I have 3 times 9. That's going to be 27. Y to the exponent of 1 times, or let's just do x first because I like to keep it alphabetical. X to the exponent of 5 times x to the exponent of 3 would be x to the exponent of 8. And y to the exponent of 1 times y to the exponent of 6 would be y to the exponent of 1 plus 6, which is y to the exponent of 7. Now I'm going to try to simplify this. Can I reduce 8 and 27? No, because I don't have a common number that I can divide out of both of these. So I'm going to look towards the x's now. X are same basis, so x to the exponent of 3 divided by x to the exponent of 8 would be x to the exponent of 3 minus 8. So that would be x to the exponent of negative 5. Y to the exponent of 1 divided by y to the exponent of 7 would be y to the exponent of 1 minus 7. So that's y to the exponent of negative 6. So my answer would look like this. I'll leave the 27 in the middle, more so. Or recall, if I expanded these out, similarly to how I did it here, my answer could also be in a different form. So my answer could also be written as 8 divided by 27 times x to the exponent of 5 times y to the exponent of 6.